Ladies and gentlemen, today I'll be presenting on mathematics. On mathematics today, I'll also be talking about geometric progression or geometric sequence. On geometric progression today, I will also be discussing finding an acute angle in geometric progression using trigonometric identities in combination with algebra. On this note, ladies and gentlemen, I was told that geometric progression or geometric sequence is a sequence where each term is multiplied by the same number to get the next term. And I was also told that that same number is called the common ratio. I was told, ladies and gentlemen, that Euclid made a contribution to geometric progression. I was also told that Archimedes also made a contribution to geometric progression. However, ladies and gentlemen, we'll be looking at a mathematical problem to solve. And our problem reads, the first, second, and the third terms of the geometric progression are sin theta, cos theta, and 2 minus sin theta. Find the value of theta of an acute angle in radians. Ladies and gentlemen, before solving our problem, we put our solution. On our solution today, we have 3 terms. The first term, the second term, and the third terms. And they are sin theta, cos theta, and 2 minus sin theta. So, ladies and gentlemen, these are the 3 terms. This is referred to as the first term, this is the second term, while this is the third term, ladies and gentlemen. Remember, on this note, based on this information given, we'll be using our common ratio formula to solve our problem. We say common ratio. On our common ratio, which is error, will just be equal to the second term or the first term, just be equal to the third term or the second term. To express it mathematically, we say it's T2 over T1 will just be equal to T3 or over T2. Remember, this is the mathematical formula I'll be using to solve our problem on our first term, our second term, and our third term. Remember, we already have the values for T2. And T2, which is the second term, will represent cos theta over. We have T1. T1 represents the first term, which is sin theta. Will just be equal to T3, which is the third term. Automatically will represent 2 minus what we have sin theta over the second term, which is T2, and automatically will represent cos theta. On this note, ladies and gentlemen, we'll be looking at our problem to solve. On this problem, we'll cross multiply. We say cos theta times cos theta give us cos square theta will just be equal to sin theta times 2, or 2 times sin theta will give 2 sin theta. What we have here minus sin theta times sin theta automatically will give us sin square theta. Ladies and gentlemen, based on these informations given, remember, we'll be sending the guy across, and the guy is negative, and bringing the guy across to cos square theta. Automatically the sign will change to positive, just to solve our problem, in order to get our perfect identity or the Pythagorean identity to solve our problem. So, ladies and gentlemen, we say cos square theta. This is negative coming across. This plus, sin square theta will just be equal to 2 sin theta. Ladies and gentlemen, we'll be using this to solve our problem. But remember, that cos square theta plus sin square theta will just be equal to 1. According to our Pythagorean identity that was introduced by Pythagoras. On this note, we say this will be equal to 2 sin theta. So, ladies and gentlemen, remember, we'll be making sin theta to be the subject, and we'll be dividing both sides by 2. So we say this will be divided by 2 and this will be divided by 2. Remember this in this person, we say 1 over 2 will just be equal to sin theta. And it can be changed around. On this note, ladies and gentlemen, we say sin theta will just be equal to 1 over 2. I remember, ladies and gentlemen, according to trigonometry that was introduced by Hipparchus, that there are trigonometric ratios according to angle theta. So we have sin theta, cos theta, tangent theta, cosecant theta, secant theta, and cotangent theta. On this note, ladies and gentlemen, we'll be making theta to be the subject. We're making theta to be the subject. It means that we'll be using sin as the inverse just to solve our problem. So on this note, ladies and gentlemen, we say theta will be equal to sin inverse. When we have parenthesis open, if we divide 1 over 2, automatically we get 0.5 parenthesis closes. Remember, to find the sin inverse of 0.5 on our scientific calculator, we press shift and we press sin, and we also put the number 0.5 and we equal it. Automatically we have our answer to be 30 degrees. So the same thing apply here. Theta will just be equal to the sin inverse of 0.5. Automatically we have 30 degrees. Remember, this is in degree, but we are not finding theta in degree. We are finding theta in radians. Remember, so therefore we'll be converting theta from degree measures to radian measure. On this note, we say note that 180 degree is just equal to pi radians. On this note, ladies and gentlemen, we say theta will be equal to 30 degree, and 30 degree therefore will also be equal to theta. So we have 30 degree will just be equal to theta, or theta will be equal to 30 degree. Just to solve our problem in order to find theta. Ladies and gentlemen, we cross multiply this count to this, one this count to this. 180 degree times theta, we have 180 degree theta. Automatically, we say 30 degree times pi will just be equal to 30 degree pi. What do? We want to make theta to be the subject. So we divide both sides by 180 degree just to have our answer. So we say we have 180 degree here, and we also have 180 degree here. Remember, and this 180 degree and this 180 degree automatically cancel. We left with theta. So therefore, theta will be equal to 30 degree into itself one time, the 30 degree equal 180 degree the sixth time. So we have 1 and we have pi. Automatically, it still represent pi over 6 radians. Ladies and gentlemen, this is our answer for today. For the proof that pi over 6 radian to be equal to 30 degree, we say pi over 6 times 180 degree over pi, just to prove. Remember, the pi and the pi automatically cancels, and we have 180 degree all divided by 6. Remember, ladies and gentlemen, we are proving this mathematical problem. Just will have 30 degree. If I divide 180 degree by 6, automatically I will have 30 degree. So you see, our answer for theta is correct, which will be equal to pi over 6 radians. Ladies and gentlemen, I remember some of the greater mathematicians who made a contribution to geometric progression today. We have Muhammad Abi Musa Akbar-Risco also made a contribution to geometric progression. And we also have Ptolemy also made a contribution to geometric progression. Ladies and gentlemen, thanks for joining me on this math journey. Keep practicing, keep pushing limits, and stay curious. And let us cross the derivatives. Always remember that mathematics is the key. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, I'm Big Boy myself Junior, popularly or commonly known as Chachi, the all-time record breaker. Thank you.